So this section, we're going to be doing operations with rational expressions. Notice that you have to know how to factor before doing this section, because that's how you actually do these types of problems. You have to first see if any of the polynomials are factorable, and then you know that you factored it correctly when you start having stuff that cancels out, okay? So you're going to look at all the numerators and denominators and see if they're factorable one by one. So here is a binomial. Is this factorable? So again, I keep saying the very first thing that you should always be scanning for is the GCF. There is a GCF. They both have a 5, and they both have at least 2 x's, right? You just take the smaller exponent. So let's factor that one first. So we're going to take out the GCF. There's going to be 2 boxes because there's 2 terms. Reverse distribute, so 5x squared times this would have to be x is 5x to the third. 5x squared times this would have to be a positive 1 would give us back 5x squared. We are done. We can't factor that anymore. This binomial is not factorable. I don't know if you've ever been taught this, but if a polynomial is never factorable, if the degree or the highest exponent is 1. Notice if we're looking at this binomial here, this is to the first power, so you know for a fact you cannot factor that at all, okay? Because we always want to look to factor completely when we do these problems. Okay, so now that's the numerator of, now we're going to factor this one. Okay, so first thing is there a GCF? Nope. No, none of the 3 terms have something in common. Then the next thing you should ask yourself, okay, how many terms are there? There's 3 terms. When there's 3 terms, a bell should go off in your head. AC method. So let's see, I'll just do the work on the side here, right? So x squared minus 4x minus 5. So the AC method says, well, let me identify. So first you want to actually identify A, B, and C. And these are the coefficients in standard form. So A is the coefficient of the x squared term, that's 1. B, be careful, is -4, and C is -5. So, so as we did a previous problem, the AC method is factors of A times C. So 1 times -5 is -5. So now we're going to do a factor tree of that, and we want to see which one of those adds up to B. So factors of A times C add up to B. That rhymes, super easy to remember. So just be super careful. It is a negative number, so you want to write a very thorough list. So either 1 times either 1 times -5 is -5, or a -1 times a +5, right? That also works. Those have to be opposite signs. So now which one of those adds up to B? Well, if I add 1 and -5, ding, 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 that's -4. If I added these bottom 2, -1 plus 5, that would have been +4. So I do want these 2 factors. Now I'm going to put a star around A equals 1, because whenever A is 1, there's a nice shortcut. You don't have to convert it to 4 terms and then factor by grouping. I mean, you can knock yourself out. I like the shortcut. So again, what is the shortcut? The shortcut is it should be 2 parentheses next to each other and then x and x. And those 2 factors are just going to go in the parentheses. So since we have a +1, I'm going to write +1. And since we have a -5, I'm going to write -5. Does it matter which of the factors goes in which parentheses? No, because of the commutative property. Okay, so now we took care of the first fraction. The second fraction, okay, so I'm going to write times. So now you have to ask yourself, is this factorable? A little hint, whenever you have just 1 term, there's nothing you could do. Okay, so both of those are monomials or 1 term, so nothing you could do there. So I'm just going to copy that down. Okay, so now that so it kind of looks a little busy. Let me take that out. So now that we have factored everything, knock yourself out, right? How do you multiply fractions straight across, right? You can do that and then stuff cancels out that way. When you do these types of problems, you always look to simplify the diagonals. That's the fastest way. So in other words, you can see here that the 5x squared cancels out with that 5x squared, right? You look diagonally. And then stuff can also cancel vertically, right? So if you notice, this parentheses x plus 1 will cancel with this parentheses x plus 1. So the final answer is just what's going to be left over. The top, you just have 3x, and the bottom, you just have an x minus 5 left. So now we're going to be subtracting fractions. So adding and subtracting fractions, you must have a common denominator. Multiplying and dividing, you do not need a common denominator. So you're subtracting, we need a common denominator. How do you do that? You have to find the least common denominator, in other words, the LCD, right? So the fastest way, just simply put, to find the LCD is you want to multiply the denominators, right? Let me just back up for a second if you're confused. So just bear with me. Let me just completely switch gears. Let's say if I was subtracting, I don't know, 2/7 minus 3/4, right? And you have to ask yourself, okay, we need a common denominator. What would the common denominator be? Well, it would be whatever 7 times 4 is, right? So you know that the common denominator is going to be 28. And that's the same thing that we're going to do in this scenario, right? So you're going to be super careful. This is a binomial. So I would put parentheses around that, right? So I would actually just do the same thing here, right? That's also a binomial. Those parentheses are going to save us a lot, or going to make things a lot clearer for us. So I always say, again, put parentheses around those binomials. Next, so we can clearly see you're going to multiply the denominator of the first fraction times the denominator of the second fraction, right? We're multiplying this times this. So again, making sure you put the parentheses is extremely important because you should end up distributing the two, okay? So the LCD, notice I'm leaving this example here just as a reference. So the least common denominator is going to be 2 parentheses 5x plus 5, right? You're multiplying them. So let me actually jump back now. I'm going to go back and forth between pre-algebra, which is what I circled. That's going to help us segue into how we do harder problems, right? So remember in this scenario, we multiplied 7 times 4 to get common denominator 28, right? So these two we know would have to be 28, right? So this is the time now. What would you do next? You would have to multiply this times 4, right? And you would have to multiply this one by 7. Okay, so I'm kind of going as slow as I can, but at the same time, I don't want it to be a 5-hour-long video. So I did make a whole course on this with quizzes and tests and lessons and warm-ups and all that stuff. The link is down below. Anyway, right? So then you would end up having 2 times 4, which is 8, and then 3 times 7, that would be 21. And then now you have common denominators, and you would go ahead and combine the numerators, right? So we're going to do the same thing back to algebra 2, right? So the harder stuff. So the same idea, right? So you're going to multiply by the other denominator. This I'm going to multiply times 2. And this one I'm going to have to multiply 5x plus 5. 5x plus 5, okay? Now we're going to do PEMDAS, right? So we have to first multiply, and then we subtract last. So in the first fraction, we have 2 times 6, which is 12. The bottom, we have 2 times the quantity of 5x plus 5. If you want to distribute that, you can, but in these problems, a lot of the, you don't really have to, honestly, but knock yourself out if you want to. I would recommend to just leave it. Okay, then the other one, we're doing binomial 3x plus 1. That's why it was important to put those in parentheses, as we did earlier, times the binomial 5x plus 5. Simply put, you're just going to be putting those together, right? So that says 3x times 1 times 5x plus 5. And then the denominator, that says 2 times that binomial, right? So 2 times 5x plus 5, right? Look at that. We have common denominators, right? So we know we did it right, All right, so we're not going to touch the first fraction. I'm just copying it down. Minus, so now we're going to simplify this fraction. And again, we're going to use the distributive property. So 3x times 5x is 15x squared. 3x times 5 is plus 15x. And then we're going to distribute the 1. If you want to FOIL, you can. I always just distribute. So we distributed the 3x. Now we're going to distribute the 1, right? 1 times 5x, so that would be plus 5x. And then 1 times 5, so that's plus 5. And then that's all over that denominator that we didn't touch as well. And then we want to see if you can actually combine like terms. So we're still looking here. Yeah, we can combine those like terms, right? So again, I'm just going to copy down the first fraction. And if you want, you can go ahead and distribute. I have a feeling some people just might want to distribute that. Okay, so we'll do that. That's 2 times 5x is 10x, and then 2 times 5, so that would be plus 10, right? Minus, again, we didn't subtract yet, so we're just simplifying. That's 15x squared, 15x plus 5x, so that would be plus 20x, and then plus 5, right? So now that we have common denominators, you combine the numerators, so that's going to look like 12 minus this entire numerator, so it should be in parentheses, right? And then all over 10x plus 10. So now the last thing that we should do is now simplify, right? So there's like an imaginary minus 1 times. So there's like should be an imaginary distribution of that negative 1. You can look at it that way, and that is exactly why all the signs should be negative. So I hope that makes more sense now. So it should end up being 12 12 minus 15x squared. The 20x turns into a minus, and then the 5 also turns into a minus. All those signs should change, and then it's all over 10x plus 10. Last but not least, super long problem. We're now going to see if you can combine any like terms. You sure can. This 12 minus 5, right? So that's going to be, I'm just going to write it in standard form, negative 15x squared minus 20x all over 10x plus 10. Whew. So we're actually done. I'm not going to show you, but if you try to factor this, because you always want to see if stuff cancels, that's the AC method. When you do A times C, there's no factors that add up to B, right? There's no factors that would add up to negative 20. That tells you that's not factorable. So just a reminder, when you multiply and divide fractions, you do not need a common denominator. So whenever you divide fractions, we're going to turn it into a multiplication problem. You're always going to keep change flip. Okay, so we're keeping the left fraction, so I'm just copying that down. We're changing it to multiplication, and then we're going to flip that second fraction. So it'll turn into that multiplication problem that we did earlier, where we're factoring everybody, if factorable, and then stuff should be canceling out. But before we even do that, I've seen people in the past, I would just strongly suggest whenever you see binomials, just put parentheses around them. So, right, because that's an entire binomial. Okay, because people will start thinking that that x and that 1 are totally separate, right? That they'll start canceling out just the x's or just the 1s. And you can't do that. So you have to think of those as that, right? That's an entire binomial. And same thing if you want, right? That's a binomial as well. So I just wanted to point that out there. All right, so we're going to try and see if we can factor everything. Now, I do just want to save some time. What's the very first step that I've been saying this whole time for factoring that you should always look for? That's the GCF method. Okay, so just to save time, if you were to look at all of these 4 polynomials, none of those are factorable by the GCF. Okay, so that's always step 1. So now that none of those are factorable by GCF, now we can start looking for the fancier methods. Okay, so I'll do this one first. Okay, so again, whenever you have 3 terms and the degree or the highest exponent is 2, that should always ring a bell in your head that that's going to most likely be the AC method. Okay, so A equals 1, B is negative 2, and C is negative 3. So I already went over the AC method in depth earlier, so I'm kind of going to move a little bit quicker here. And again, I have a whole course on this if you're interested, link below. Anyway, all right, so AC method, because A times C, so that's 1 times -3 is -3. You're going to always do the factor tree, just keeping in mind you account for all of the signs, right? And then you're trying to figure out which one of those adds up to B. In this case, we're looking for -2. So if I add those together, that's going to be -2, ding, 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 right? And if I added those two together, I would have gotten a +2. So these are the guys I want. Now, what's nice about the fact that A is 1 is whenever you have A is 1 problem, you can do a shortcut. And that shortcut is you're going to end up multiplying two binomials together, so two parentheses next to each other. And then it'll always have both of those first terms as X. Okay, that's the template. And then what you're going to do is just pop those factors right in. So 1 is positive, so I'm going to write +1, and 3 is negative, so I'm going to write -3. Done. Okay, so if A was not 1, then we'd have to use those factors and rewrite the middle term and factor by grouping. Knock yourself out. You can totally do that, but I don't know why you would. Okay, so now I'm going to erase everything and just substitute this in that spot. All right, and I do also want to add, could I have written X -3 and X +1? Yes, because of the commutative property. All right, so now let's see if that's factorable. Okay, so whenever you have two terms and then it's a difference or subtraction, that should be a sign in your head that maybe it could be difference of perfect squares, and it will be difference of perfect squares. So that template is 1 is plus and 1 is minus. Now, what goes in the first slot? It's always going to be the square root of the first term, right? So both of those terms are perfect squares. That's why we can do this. So the square root of x squared is x, right? And then what goes in that second spot? That's going to be the square root of the second term, right? Which is 2. Okay, done. So x +2 and x -2. So I'm going to erase that and now put that in that spot. Next, again, over here, we have three terms and it's quadratic. So you definitely are going to try the AC method here. Oh, good. We have another A equals 1 problem. So we can use that shortcut again, nice and easy. So 1 times 10 is 10. And then you're going to go ahead and list the factors, but also keep in mind you have to do the signs as well, right? Positive times positive and negative times negative. You can actually stop, right? Because when you add these up, you get 7. When you add these up, you get -7. And again, we're trying to figure out the factors that add up to be +7. So our chosen factors are going to be +2 and +5, right? So again, the template, when you have A equals 1, is it's always going to be 2 parentheses x and x. And now we can substitute the +2 and +5. We are done. You could have also written that 5 term first. All right, last but not least is this factorable. So I will tell you right now, whenever you have two terms and the degree is 1, which it is here, the highest exponent is 1, the only way it's factorable is by the GCF, okay? When it's linear, the degree is 1. The only way it's factorable is if there's a GCF. There is not. So it is not factorable, okay? And again, putting the parentheses around x +1 like we did before can help us clearly see that diagonally, when we see what cancels out, this has a parentheses x +1 and this has a parentheses x +1, okay? And then diagonally, the x +2s also cancel. And then you have to see if things factor vertically, right? So do these cancel? No, they're not the same. So now that we have fully simplified, now we can multiply fractions. How do we do that? Straight across. So our final answer is going to be x -3 times x +5 all over x -2. You don't have to put parentheses now over x -2. You can if you want. And you don't have to FOIL the top unless your teacher tells you to. So we're done with operations, right? We don't have adding, subtracting, multiplying, dividing. You just have one single fraction. And I'm now asking you to divide those. So after I divide this trinomial by this binomial, what's the actual answer? What's the quotient, the exact quotient that we get? So the two ways that you can do it is long division or synthetic division. Now, we cannot use synthetic division. Synthetic division, you can only use if the degree or the highest exponent is 1. Okay, it has to be linear. Unfortunately, it's not linear. Notice it's quadratic. It's to the second power. So again, the synthetic is a nice shortcut, but there is a catch. So it looks like in this case, we are forced to do long division, okay? So again, I have this in my course where I have like the full lesson and I go a little slower, but for now I'm just kind of going over it. I will, let's see, write the steps on the right-hand side. So first things first, the long division symbol goes like that. So you always put the dividend, what you are dividing, inside the long division symbol, and the divisor, what you are dividing by, always goes on the outside. Okay, so now that we have that long division set up, the steps would be, so this is in like my personal words. We have, I'm just going to write match. Okay, and what are we trying to match? We're trying to match the variable terms only. Okay, and then very specific matching. We're matching the ones with the highest exponent. Okay, so I'll write that in parentheses. So what do I mean by that? So this has the highest exponent and this is the term with the highest exponent. So those are the ones that we're trying to match. And by matching, I'm asking, what can we multiply by, right? X squared times what can get us to 2x to the third? 2x, right? Now, after we have matched, what I'm then going to do is you're going to multiply. What are you multiplying by? You're multiplying by the entire divisor, okay? And I want to stress the entire divisor. So you should be distributing here, right? Because remember, the entire divisor, the entire divisor is a binomial. I just wanted to fix that because it was bothering me. Okay, so we should be distributing that 2x, whatever we have matched, okay? So 2x times 2x squared, which is 2x to the third. Notice they match. That was the whole point. And then 2x times 1 is going to be plus 2x, okay? So after you've multiplied by the divisor or distributed, now it's time that you are going to subtract. Now, I do just want to say, be super careful. You are subtracting the entire binomial, okay? So I like to, you don't have to, but I like to just put parentheses around it just to remind myself that I'm subtracting both of them, because people will do a good job and they'll subtract those. By the way, the whole point of matching is to cancel out. And then they'll forget, they'll do negative 6x plus 2x and they'll get negative 4x. You're always doing top minus bottom. So that is actually saying negative 6x minus 2x. So you should end up getting a negative 8x. Okay, so that's a super common mistake. Okay, now you're going to drop down the plus 3. So this is where we're at. So now we have to figure out, can I repeat this process again? Okay, so again, let's go back to the first step. The first step is we want to match. So can I multiply x squared times anything to get to negative 8x? And the answer is no, okay? Because the degree is 1 smaller than the divisor, right? This degree is 1, that degree is 2. There's no way that can happen. So when you end up getting something that's 1 less, you're definitely done. So we can't repeat this process again. So when you are done and you can't go anymore, this is now what's called the remainder. So we can say that x squared plus 1 goes into that trinomial 2x times plus that remainder, right? So it's kind of weird when you're talking about variables. But we're not in elementary school. You can't just write r and then that remainder, right? So how do we write that? So in general, the final answer, and by the way, let me just back up. This 2x, what is that called? Let's see what color. This is called the quotient. So the result after you divide. Okay, so how do you write the final answer? As I was saying, you always write it as the quotient. So in this case, 2x plus whatever you get as the remainder over or divided by the divisor. Okay, so that's the general rule of thumb. So doing it specific to this problem, so that's going to be 2x plus the negative 8x plus 3 goes in the numerator, and then the divisor was x squared plus 1. So this is the final answer. I hope you found this video really helpful, and I want you to make sure that you check the description. I left links to also my online course if you're interested. I have chapter modules and quizzes and homeworks and step-by-step answer keys, and I have video lessons of those. So again, I left that link in the description. Make sure to like and subscribe, and make sure that you also leave a comment so that if you want to also request any future videos, I'd be more than happy to make those. So I hope to see you soon.